Alright. Alright, chat, let's go. Let me pull up the stream. Alright. So today we gotta do more F extensions. So yeah, let's just do it. We gotta go to F. Alright, yeah, we're here. So yesterday we tackled f add.as all the way down to f max. We got all the way down there. So now we do the rest. How many more do we have? So we have one all the way down. That's still a lot, not gonna lie. It might take, maybe we can get it done by today, but probably tomorrow. Might be a tomorrow thing, but let's see. Let's just see how the progression flows and we'll do it. Alright, so let's start with fm add. So we gotta do that first. Let's see how that is. So layout of bits is so we got an RS3 here. So that's gonna be interesting to implement that. But it does occupy the same bits as our funct5, so I'm not really sure. Opcode is different. But now we don't really have any distinguisher except opcode. Opcode's gonna be different for every single one here. Seems like. So yeah. I think it's just better to implement funct5, not funct5, RS3, because it just will improve readability, to be honest. Does it make no sense to really name it in here? Because the thing is, so let's give an example, right? Yesterday we used funct3 interchangeably with RM. But that wasn't actually used in our actual interpreter for like writing to registers or reading values, so I don't think that matters. But for this one, it kind of does matter, I feel like, and also in here we actually use it, so for the introduction, so it wouldn't make sense, I guess. I guess, yeah, that's fine. Maybe we should have actually changed that one too, to be honest. It's probably better to do rounding mode. Make like a new function, probably just make that. It's probably more distinguishable, probably, to be honest. And it's probably better to change it now itself. Let me take a look for a second. So FCSR, is that not in here? Okay. Is our so I probably won't implement that, but I'm just not sure. Yeah, maybe it's better to make it separate, to be honest. Yeah, I think we can do that. So that would mean in our decoder we have to actually make it separate. So we'll do it here. But it's essentially the same as the func3, so just copy that over. Same implementation, so. Yeah, it's not really a big deal. Maybe just can't do that, that's fine. You know, just in case any implementation gets changed in the future or anything like that, it's probably just best to do that, to be honest. So then, in later down in our decoder, we have to actually change the value here to actually match that. So let's call that let's call it R. Or it's fine, just call it RM and then have it here like that. And initialize it with RM. Same with the value. And yeah, that should be fine. This will make it at least better, to be honest. So let's go down. It will change here, so starting from should be starting from FS. We'll probably change it, but I'm not sure if we need to change it for F float word, to be honest. Yeah, I think we can keep it as func3, right? I think that would be fine. I think just changing it for the specific ones here, FADIS, so. Well, these are already just by func5, but here, so we need to change it to RM, so it's easier. Because that's how you distinguish these, right? Let's take a look. Which was that again? Fmin, Fmax. So Fmin, yeah, that's the only way to distinguish them because their rounding mode is separate. Because their opcode is the same and func5 is the same. So the only way to distinguish is RM. So we need that there. So yeah, that should be fine, and same with the rest. Oh, that's fine. That's fine, to be honest. Honestly, when I refactor this, I'm probably gonna we have like a huge if else, so we'll probably make this like a switch case statement. To be honest, that might be a better option, to be honest. It'll be like switch opcode depending on the opcode, and then further down. So we'll refactor that later. So we'll make this a switch case instead at some point, which will be based on the opcode will be the switch, and then further the cases will be like func3 stuff like that. I think that would be a better solution for later though. Let's first make sure we get everything. We don't want to optimize too early. As long as you have all the logic, it should be fine. So yeah, I think that's fine. All right, fm add is the next one, right? So let's see how that is. So that's the opcode. Let's get the opcode in binary. I believe it's 4 zeros. Yeah, 1000 and then 1. That'll be hex 42. We'll keep that for later. We still have to implement. So let's actually go and change. First, I'm gonna check the implementation. It's up here somewhere. Yeah, fmadd.s. So it takes in source register 1, multiplies that by source register 2, adds source register 3, and then implements that in there. So that's interesting. So yeah, let's do that. So make enum class. I'm gonna rechange this. I forgot. I need to change this. This will be fp score r1. That'll be better. I'm really terrible at naming, so I need to use this to actually get the naming right. No, I meant the an R4 type. Does it though, really? I don't think it does, right? Wait, let me look. No, it doesn't really. No, it doesn't. Yeah, Claude, Claude is getting stuff wrong. I'm just gonna do my thing. FPR4 is fine, I guess, yeah. FPR1, FPR4, that's a good way of distinguishing. Well, I'd want this one to be over here. Like I wanted to follow the order, so yeah, this one can be over here. So now it follows the order. FPR4 will be for those. Max. Why is it 4 registers? PR4 type, yeah. But they really don't though, Claude. I don't know what you're talking about. Yo, what's up, Hazy Mans? How you doing? Wait, let me take a look. So, okay, I see what he's saying. Okay. Yeah, print format is slightly different. Like very slightly, but it's, yeah, we have to make the change. Okay, for FPR4 type, let's just get all of them in now. The ones that I know so far. S. Let's see. Okay, those two for now. That's what I know. So we'll keep these two for now. Okay, so structure FPR4. And it will be in our decoder. We have to change it properly. So in our decoder, we'll have I just typed it so badly. Alright, with one register. This will be a floating point. R4 type. Oh my god, dude. Okay. It's getting low-key tedious to write these out, bro. Oh, dude. And we also have D instructions. Bro, you know what? I I might skip out on double instructions for a bit. Like after the floating point is done either today or tomorrow, we might just move on to pipelining. Maybe revisit double. Because like if I have to do this whole stuff again for double, like how am I actually gonna get burnt out? So yeah. Finish out the floating point and we'll implement double later. Okay. Got first do it in our here. Alright, so in here, oh yeah, we need to change these because I changed this thing. Type is now FPR1, I believe. Yeah. Same in the interpreter, we gotta change that. Or actually, no, it's fine in here. Nothing changes in here, it's just in the decoder. Okay. Now let's actually look here. FM at S, and that will be under the FPR4 type. And we want to get, what are the values we want to get? Okay, let's look. So for FM add.s, we need, it's a bit slightly different. So it's, we have all these so far, but we also need rs3. So we need to implement that here. So install rs3, get rs3 value, and have that like that. What is our function called? Let's get rs3, right? Oh, we never made rs3, that's why, sorry. Alright, I gotta make a separate one. rs3. And rs3 is essentially just func5, so it's literally just that. I'll double check in a second. Yeah, it should just be that. We just want it to be separate, so like if anything changes or like we actually need to access it properly with it, it will be kind of confusing if we just use func5. So we need, even though they're the same function, we need to separate these containers. Yeah, it takes bits 27 and 31. It's the same. It's literally the same. It just replaces that. Alright, so, okay. I understand. Alright, that should be fine. Now when we go back here. Oh, we also need to change that into decoder instruction. Struct. About that. All right, there we go. Now it should be fine. Everything should be perfect now. All right, one thing I do need to change here is we're no longer identifying by func5 itself, so that's out, and not identifying by rounding mode either. What we are identifying by is opcodes, because now opcodes are different. So for fm add.s, we have an opcode of this, which is, this will be something in hex. I need to see what's in hex. Every opcode is different here, I believe. So from now on, we just can look at opcode. Just for these couple ones. Yeah. Alright, let's see. The opcode for that one was 43 in hex, so. Does anything else have 43 in hex? I don't think so. Yeah, no. See, that's fine. Okay, I think that's good. Now we can do the other one too. It'll be sub s, and then essentially the same, just the opcode is different. So the opcode will be wait. Okay, yeah, I got it. So it's a one. It's hex 47. And it's this one. Alright, there we go. Alright, that works. That works, and alright, just making sure my audio is fine. Just making sure. Alright. Alright, add.s. It's done. Sub.s. Now we need to do f. Well, actually, let's implement them in the interpreter first. Alright, so these, I just want to make sure this is right. Okay, yeah. So these two remaining, let's implement those. Well, first let's do the registers first. I don't want to move on before I get the registers part for those two, and then we'll add the other two. Alright, registers. Alright, let's do it. I'm just gonna copy this simply first. Alright, so we're gonna be looking for fm add s. If the instruction is that, and we need to see what exactly we're doing. So the format will be, let's go in here. For fm add.s in risc-v, it will be rs1 multiplied by rs2 plus rs3, and then storing that in destination register. So let's do that. So we're fine here, we don't need this, but we will do it here. So should I make variables? Might be better too. Yeah, let's keep variables. So go back. Let's keep these variables we deleted earlier. Alright, so we'll keep these. We don't need this function anymore, so it's fine. So now, I think maybe that's a mistake I made. I was doing the arithmetic without storing variables, but I guess it's fine. For the most part, it's readable for the other ones, but I did it where it's not as readable, so that's fine, I guess. Most of the time, it's kind of readable, I guess. I don't know. If it's ever needed, I'll refactor. I guess it's good to just have variables when it gets confusing. So now, let's see. So rs1 multiplied by rs2 first. And after that, we'll be plus rs3 plus rs3, and yeah, that should be fine. That should work. That should be pretty beatable. Same, we'll do the same for fm sub s. Fm sub s, it should just be the same. It's just subtraction there, so yeah. rs1 times rs2 and then minus rs3. So yeah, that's fine. Just make sure I got everything. Yeah, I think that's right. We'll do a quick check with Claude just to make sure I didn't miss anything. Yeah, I don't think I missed anything, but let's see. There's a more precise way to compute fuse, multiply, add. C++ has... Oh. Oh, okay, I actually didn't know that. Okay. Assisted FMAF produces the multiplication addition as a single operation with only one rounding step, whereas that does two separate operations with two rounding steps. Requires, okay, so risc-v aspect requires a fuse behavior. That's the whole point of fmad. fmo plus fadd. Okay. I mean, yeah, that makes sense now. There's a reason why we're not combining those two steps. But I want to take a quick look at what that is. Give me a second. Because there's different types, so... Okay. Okay, that's interesting. Okay. Alright, I guess we can use it. It's a better way of doing it, so I guess we'll use that instead of doing it like this. So oh, that should be here, and then we can just move this and not have any operations in here. Yeah, I mean, that should be fine. That's how he did it, right? So this will fuse, multiply, add. So multiplies these two and then adds with only one rounding step, so it doesn't cause any problems. Okay. Well, wait. Well, that's for adding. This one's for adding, so... I wonder what's there for... No, this still needs to be there. This... I actually put an extra one. Alright, there we go. What is there for this one? Oh, okay. If you want to specify, you just need to put it in front. Okay. I was wondering how to get the subtraction one. Okay, that works. Okay, I'm glad that Claude told me about that part, because that would have caused problems later. Alright, last two. Last two for this part so far. Fn of sub. can add that in our enum table here. It also has S too. Alright, that's good. And what else do we need to update it in our decoder here? Okay, that's good. And then down here, we will change it in here. So, what is the opcode for this? Let's see. First, let me change the name. FM sub S. This also takes the same values as these, so that should be fine. Just the opcode separate, so let's see what the opcode is. Okay, that's 4B. And then the last one, which will be FM add S. Oops. Right, there we go. And opcode for that one, let's see. FM add S. It's 4 ones, right? 1001. Yeah, so 4F is the opcode. Alright, that's good. Then implement in our registers. And in this case, FNM sub S takes in a negative. It's the same, but it's just a negative RS1 value. So it's gonna be positive there and then negative here, because it's adding negative RS1 and then adding a positive RS3. So yeah, it should be fine. And then same thing with our, in the case of our addition, FNM add S, we'll have let's see, what was the spec like? For this spec, it's also a negative RS3, so that stays the same as negative RS1. Okay, I think it's good. I think that's good. Let's look at what the next stuff is like. So we have done a couple so far. Our next one is converting instructions. These will take in the name, destination register, RS1, RM. Does anything similar to that? Square root is RD, RS1, RM. RD, RS1, RM. Okay. What did Claude recommend I do for that? Min max fmin.s. So he recommended making a separate category for CVTWS, but I don't think we should make a separate category, should we? It's essentially the same in printing though. Wait, print format is the same. They share same tab looking at the formats. FPR1 prints that FPS destination or FPS source. Oh, okay, this works on integer ones. That's probably why we can't have the same. Oh, I should have read it properly. Signed to integer, so it has to be the integer register, so we won't. Well, that only matters for. The print format is the same for both, right? Because up until now I've just been putting them like this. Oh, I need to change this. I forgot to change it earlier. I need to change these. Claude might say something about this. FP instructions, you need an F prefix, so FPR1 would print. Yeah, they use F prefixes, so. Okay, I made a mistake. Definitely made a mistake. That was kind of oversight on my part. Like, okay, let's see how much we messed up. FPA, right? FPA starts here. So okay, good thing we only messed up these two. Okay, I need to redo these two. I'll probably do that in a second. That was a complete oversight on my part. I totally forgot that their prefix is F. So okay, good thing I realized that. Good thing Claude caught that early, because that would have been bad if I had to go refactor a lot. So that's fine. We only messed up those couple ones, and then this is just I need to do this. Hey, what's up, Greg YT? How you doing? Okay, that would mean that we do need a separate thing for these. Let me go fix these real quick. Let me just make sure everything's fine here. Let me just give to Claude these to make sure. Like this. Oh. I meant to do RD, not FMT, that's my bad. RD. Not RD, RM. Yo, stop being wrong. Change that now. Okay, that's also a problem here. We need to be instantiated here. In our struct. Alright, let's give Claude these to make sure I made it right. Those are needed, but printing RMS still has the same issues. T is a numeric value, that means nothing to user without context. Field assemblers either omit it when it's the default. Yeah, but in the spec it says it's always printed though. I'll just get a screenshot and show Claude. Dude, Claude, make up your mind, bro. Dude, holy dude. Why is like Claude actually contradicting himself like every message? Okay, printing as a raw number like 07. It's not real assembler show it. The mnemonic names. Oh yeah, that makes sense. I saw it up here. Yeah, the mnemonic names are up here in the spec. I'm just gonna check another website just in case, to be honest. But a different website shows they don't include that, so I don't really know. Okay, let me query, because a different website says it doesn't have it, so. RM field is always encoded in the instruction bits. That's fixed. The question is just whether they're printed in the disassembler output. Looking at real assemblers like obj dump, they simply omit rm when it's dyn or rne, since those are the defaults. Only show when it's a non-default value. For your emulator, simple approach is to omit it. From printing entirely, we're not implementing routing modes in execution anyways. ARM field is still stored. If you need it later, you just don't display it for now. Okay, we'll omit it. We'll omit it. We don't really need it, so we'll omit it. I think because if it's 0, it's not beneficial to print it either way, so we'll just omit it entirely. Sometimes it's good to just have like a chat with Claude, just to like kind of figure out what's going on. Although I can tell it's kind of confused sometimes. It kind of like admits defeat too fast at some points, to be honest, Claude. Like, I would hope it would like hold its ground a bit more. No, but like, it's whatever. Alright, so we'll get rid of that. We don't need that. So it'll just be that, and then we'll also make the else if for that. Instant name. What are we looking for? R4, right? R4, yeah. And R4 is a bit different, so we have that. Because then we have RS2 value, and then also RS3 value. Yeah, that should be fine. That does fit the specs, so it'd be like fm_add.s, destination register, register 1, register 2, register 3. Okay, yeah, that works. Yeah, and okay. Just show cloud. Let's show cloud. Oh, commas, totally forgot. Yeah. Let's just make sure the commas are right. f_add.s. Oh, it's just commas after RD, not before. Yeah, after RD. So that's fine. Yeah. And now let's fix our error. Let's fix our error up here. We need to implement the other ones too. FLW and FSW. Yeah, and these will be our two separate ones because these two are the only ones that use an immediate value and floating point, I believe. Yeah. So they'll be distinct. We could call it like FPLS or something for load store, load/store. Down here, floating point, load/store. And those two will be FLW and FSW. Yeah, that's fine. Implement it in our decoder too as well. I have one up here. Wait a minute. Oh yeah. Yeah, okay, we're good. Right before the arithmetic. So FP load/store. Welcome back, Greg YT. What is the problem? What's the problem? Oh, I forgot it. No, I did. Oh, what the? Oh, right, I already added them in here, but we can't have them here anymore. So delete that and delete that. Okay, that should be good now. Now they're distinct and we can include them in the register. Oops, what did I do? They're pretty close to the these two are also different. Okay, we can't do this then. We have to also separate them again. So this one will just be FP load, and we'll make a separate one. FP store. So FP store is here. Okay, now it'll be simpler to write it out. Let's look for the load one. Right, the load one is essentially the load, but just with floating point registers. So just have to change the register names. The name. So load takes in destination, and this one takes in rs2. Yeah. This will also be enough. And now we need the store ones. Oh, we want to change the name. Forgot. FPL. So we have FPS. So we have FPS. And all we have to do is just change this. Okay, I think that's good. We will need to change stuff in here though. We'll need to change their category. Oh, not the instruction name. Instruction is the same. FPS. Everything else will be the same. Okay, yeah. Everything else is the same. I just want to quickly check this with Claude. Make sure I separated everything fine. The base address register is always an integer register. X4 is integer. Funds float. Let me see. Loads a single precision floating point value from memory into floating point register. Wait. Let's query that real quick. Yes, I will add the min-max block. 1 second, Cloud. We can actually just check in here, to be honest. Well, he didn't really say what it is. Oh, it is an X. It is an X. Yeah, okay. So it is an X. The memory address of XR1 and XR's one over here. So yeah, I made a mistake with that. Okay, what else did I miss? What else? Also still missing commas in FP and FPR1. I thought I added them. Oh, no, I didn't. I did not add them. My bad. And FPA as well. Okay, that should be fun. Okay. RS1 base should be X. Okay. Alright. I guess the next part is up now. After we do F min max, which will be here. What does min max take? Min max takes 2 registers stored in 1 register. So that's most similar to like an R type, I guess. Right, yeah, it's most similar to R type, we just have to change the name. FN max. And it will take floating point registers. Yeah, all floating point registers. So just change it to F. Okay. Oh, my account got hacked and got disabled suspicious activity. Your Discord account? Yeah. I mean, man, you must have done something, bro. Maybe, like, you just didn't realize at the time, but that's probably why. It's fine. You can just... Can you not, like, recover it? Like, just reach out to Discord and get it recovered. I'm sure they handle cases like this all the time. Okay, that should be fine. Now let's actually move on. We fixed all our missing stuff. How many more do we have left? 2, 3, 4, 5, 6, 7, 8. We still have a good amount of 10, around 12, 11, something like that. Pretty sure we might finish on stream tomorrow, to be honest. Floating point. Then we can actually move on to pipelining, so that's kind of exciting. Okay, so we have FCVT. Where is FCVT? FCVT is here. First one up is FCVT WS. Here. So FCVT WS, it takes in Yo, welcome back, Rex and Noctis. Okay, wait. Destination register and RS1. So for that number, wait, I'm a bit confused with this one, to be honest. Wait, give me a second. Hey, what's up, Reason? Okay, wait. Convert the floating point number and floating point register RS1 to assign 32 bit an integer register RD. Okay, so oh, so the integer register is RD this time. Okay. So I think we would need a new spec here. We need a new class here. Let's call it FCVT, because they're all like CVT. Or is there a better name? Let's see. What did Claude give me for the name earlier? I totally forgot. Oh, okay. Some are converting to int and some are converting to floating point. So we need to actually like name them right. So let's call it PC int, I guess. That's a decent name. It's fine. We'll just call it the full name so it's not too confusing. Vconvent. And we'll put them in here underneath the offer types. And that would be floating point of integer registers. Reg, and we want what exactly are the floating point to integer forms first? Let's take a look. Alright, so this one's floating point to integer. This one's also floating point to integer. Okay, wait. I think I got it. the FCTWS one first. FCVT WS. Good luck, have fun. I appreciate you, Imperial. Let's not overthink it for now. Let's just do one at a time. We'll add more as we go. Let's not like get all of them in now. Let's not overthink it. Let's just do it one at a time. All right. So we have the convent one, which needs to come in our one here. So floating point to int switch. Does it tell you when it overflows? Yeah, for a floating point, it automatically does overflow. It automatically like covers that. For integers, I had to cover overflow properly though. A floating point with the IEEE 754 standard, it should cover it automatically. So that's a good thing about floating point. FP, totally forgot for a second, wait. FPC T WS. Did I write it wrong or something? Oh no, it's just FC, not FPC. Here. Then we'll type the actual version of it with all the dots and stuff. .w.s. Floating point to dynamic rounding or always towards 0? Pretty sure it's dynamic rounding. I'm pretty sure in some cases it can go to infinity, some cases it can go to not a number, some cases it could go to 0. It really depends. It depends on like the values of the exponent and the mantissa. There's like a table for it. I haven't memorized that table, but I will. Yeah. Okay, then let's change our F-SIFs. So what distinguishes these? So for this one, it uses a funct5 format, rs2, rs1, rm, destination, and opcode. So I guess distinguishing them is a funct5. Looks like their rs2 values are automatically 0. Yeah, so opcodes are same. Funct5's main distinguisher here. So let's look for the opcode first. So for this one, the opcode will be 1010011. Opcode is 53. And the funct5, which is equal to something. That's 18 hex. Alright. Yeah, that should be fine now. That's a good distinguisher of them both. Let's change the name of them. And this will be and the values it takes are rs1 and rd, so we don't need rs2 and rs3. We can get rid of those for the initialization. Yeah, we can keep the rest here. Okay, now we can implement in registers. now we need to rethink this. All right, so let me just get rid of all this. All right, so how is it implemented? Let's see. Let's go back to the specs. So for WS, convert floating point number in floating point register RS1 to assigned 32-bit in integer register RD. Okay. Let's initialize our. So we're writing to the regular register. We're not doing writing to the floating point register. So we'll have RD, but now we need to like do a cast. So we need to do a proper cast to get that floating point value in. I'm pretty sure. Okay, so let's just initialize our float. We'll set our float f as inst.rs1. And that would be reading from a floating point register, so we need that. And is it an unsigned integer or a signed integer? It's a signed integer, so we need, okay, unsigned integer, we just need a regular signed integer. And let's call it value. And just initialize that as just any value. And we need instead risc-v. So the order was okay, so we want that to go to that, so we want the address of value, address of f, so the address of f, the value, will go into address of value, and then size of value, and then storing value in here. It's.rd. So that should be the right way to do that. If I'm not wrong, if I haven't missed anything, I think that should be right, but let's just check. Let's check everything. So let's give Cloud this, and let's give Cloud the other one. Oops, I accidentally pasted, not copied. And wait, one more thing. Let me check one more thing. I don't know if we need a cast back to unsigned integer. Do we need to sign back? Cast back? Okay, Cloud will catch it if we need a cast back. For now, we'll just check. If we need a cast, then it'll be fine. Let's see. Code looks correct. Basic logic has a bug using memcpy, which reinterprets bits, but should convert the floating value. Reinterprets the bits. Oh, we're not reinterpreting the bits. FCTWS. So float word floats store word was a bit reinterpretation. Memory doesn't know what types, it just stores bytes. When you do for W, memory has 4 bytes that represents the float's bit pattern. You want to take those exact bits, put them into floating point register. We're not able to work on anything so far. Yeah, get to work, man. Get to work. I kind of did wonder, why were you doing like the end game stuff if you haven't even done like the beginning though? EXO. 3.14 in memory. It's like that. So we want to get the register to contain that value, which means the same bits to end up in the floating point register and interpret it as a float. Okay. Here we have an actual float value, like 2.14f. Sitting in a floating point register. And you want to convert that into multiple value into nearest integer 3. Oh, okay. I see where I went wrong. I kind of overthought this, to be honest. Yeah, we don't need all this then. So this will be that. Static cast. So can you just static cast that like to that value, like to assign 32-bit integer, just like that, and then just put f in it. So I'm going to do all the events, then make a script that will change the events weekly, and then I'll do that as many times as I can. Yeah, but what about the main game though? Like, I get that like you're doing all the other stuff, but don't you need like a base game first so you can add on the extensions later? I feel like you're going too deep in, and then you realize that you don't have a base game to work with, so like get the actual base game implemented first so you can figure out what you can do after with that. I know probably doing the base game gets boring at times, but like that's probably like a really important step. And then casting it back to an unsigned int value, probably. Oops. Let me see. Yeah, I was right. Yeah. Static casting back. Yeah. Just so I'm gonna put this in. Okay, that's fine. And okay, that clears up any confusion I had with that. I think I'll do a couple more and then head out probably. Let's do the next one. I know, but I'm going to only do the layout, build the entire base game, and then have the systems. Do you have like someone else coding the base game for you? Is that what it is? Then shouldn't you do the base game first then? Because you're probably gonna run into the same issue you had last time for the last game that you made, like the last one that you tried, like you were like making all like the side missions and all the extra accessories for the game, but you didn't actually have an idea for the game, so you had to scrap that. Average solo dev suffering from side quests. Yeah, that's real. That's real. I didn't even implement it yet. Wait, what's it called? What should I call it? Converts to 32-bit signed integer. Treasures 1 to a floating point number. So I guess just the other way around. Int on FP. Oh yeah, that should be fine. This will be an integer to floating point. I get that it's fun, but you have to be kind of disciplined and at least get the base game done. It doesn't even have to be like extraordinary. At least getting like something so you can actually work off of that. Because you need to understand how like the extra mechanics that you're adding in will like tie into the base game. Like trust me, you will find it much easier to actually do everything else if you at least get the base game. Okay. SCVT, this is SW. And we can implement that easy as well. Edit color. .w. Increment to FP. Okay. And then put it in here. Which will pretty much be the same, but just a different funct5 since they have the same opcodes, I believe, if I'm not wrong. Yeah, same opcodes, but the funct5 is changing. 11010 1A. At some point, I'm gonna need to memorize the hex. I just can't do arithmetic with hex as well as I can do it with regular. But at some point, I need to memorize the hex, so I don't have to keep going back to that website to convert. All right. SW. This will be integer register too. Yeah. Okay, and I'm pretty sure it's the same. It just takes an RD and RS1. Yeah, it does. So now we can move on to the register part. Based off the mistake we made last time, we'll actually be able to do it right this time. Okay. So for this one, we need kind of just swapping these. So reading the register here, but it's gonna be like a static cast though after. So this value here will just represent any value, so it'll just be RS1. And this value will be a static cast of that to a float. Is that the right way to do a static cast to a float? just the value. I'm usually used to static cast with ints, but maybe static cast with a float is there. So we writing to a floating point register, and we do not need a static cast here. It will just be F. Totally forgot about this. There we go. I think that's fine. There are also unsigned variants that you might want to add later. Yeah, I will add those later. But to be honest, I think that's it for today. Not gonna lie. I think we can carry off start off tomorrow. How many more do we have left? So we did these two, so it'll be around 10 more. It should not be too bad, but yeah, I think we'll carry on tomorrow. I'll see you guys.